Okay, continuing on with number 8. This is polynomial long division. So we have 4c squared minus 33c minus 27 divided by c minus 9. So I'm basically asking the c, I'm looking at the first term each time. So what times c would be 4c squared, and it would be 4c. So 4c times c is 4c squared, and then 4c times negative 9 would be negative 36c. Now since we're subtracting all this, we're really like subtracting this and adding that. So it ends up being 3c, and then we're going to bring down this minus 27. So now c times what is 3c, and it's 3. So we're going to multiply that again. So 3c minus 27. And when you subtract that, it's going to be the same, right? So we're going to get 0. So our answer is 4c plus 3. And you can always double check by multiplying this times that to make sure you are correct. Moving on. Number 9. We have 14x cubed plus x squared minus 3x divided by 2x plus 1. Same thing, 2x times 7x squared is going to be 14x cubed, and then we have this plus 7x squared. Now we're subtracting, so it's actually minus and minus. So we have, I don't know, I'm switching colors here. So positive 1 minus 7 is negative 6x squared. Bring down the minus 3x. 2x times negative 3x is going to equal negative 6x squared minus 3x. So again, when we subtract, it's going to be that, and we get 0. So our final answer is 7x squared minus 3x. Again, you can check that by multiplying that times this and seeing if you get that. All right. Moving on to 10. We have 4 over b plus 11 over b, and the instructions say add or subtract, so that's easy. They have a common denominator, so we can go ahead and add them. So we get 15 over b, done. Number 11. 3 over g minus 2 over g plus 1. Now here, we need a common denominator. So the factors are g and g plus 1. They have nothing in common factor-wise, okay, because this g is not a factor. So the whole thing is g plus 1. And so the common factor is going to be, so the least common denominator is going to be g times g plus 1. So in order to give this a g plus 1, we have to multiply both top and bottom by g plus 1. The reason this is legal is because g plus 1 over g plus 1 is 1. So we're actually only multiplying the fraction by 1 to get it to look the way we want it to look. So the right fraction already has g plus 1, so it already has this, so it just needs the g. So we're going to multiply the top and bottom by g. And so now we're left with the top, which will be, I'm going to distribute this, so 3g plus 3 over g times g plus 1 minus 2g over g times g plus 1. Now they have a common denominator, so I can combine. So 3g minus g is g, and then we have a plus 3. Or I don't know what I said there. 3g minus 2g is g, and then plus 3, and then over g times g plus 1. Now, to reduce, you cannot reduce the g's here because this is a term. If this said g times 3, then you could reduce them, but it doesn't. It says addition. So we are done. This is now non-reducible. That is the final answer. Moving on to 12. We have 4 plus p over 2p minus p minus 1 over p. Now in this case, the factors are 2p and p. They do have something in common because these are all factors. So p and p are the same. So the least common denominator in this case is going to be 2p. It doesn't have to be 2p squared because this has a p and this has a p. So we don't need to have any extra p's. We just need a 2. And so the bottom one here is fine. To fix the right one, we need to multiply by 2. So we just 2 over 2, which again is legal, not because we're doing it to both sides, because there aren't both sides, but 2 over 2 is 1, so we're not changing any values here. We're just making it look different. So we have 4 plus p over 2p minus, here's a trick, because this minus counts for the whole top here. So it might be effective to say minus 2 and then in parentheses p minus 1, because I know so many people are going to make this mistake, even though I'm warning you ahead of time. So it's going to be 4 plus p minus 2p. And now 2 times negative 1 is negative 2, but it's minus negative 2, so it's plus 2 over 2p. Now we're going to combine like terms on the top, so 4 and 2 is 6. And then p minus 2p is minus p. Okay, again, there are no factors in common here because this is a term, that is a factor, cannot reduce. So it's 6 minus p, or negative p plus 6, but that is it. Number 13. Okay, so in 13 it says in order to add 4 over x squared minus 49 and 5 plus x over x minus 7, it is necessary to find the blank first. Well, it's common denominator. LCD would be a good one too, least common denominator. And what is the sum? So first we need to find the LCD. Well, it just turns out that this is a difference of squares. So if you factor it, it already has an x minus 7. So it doesn't need that. So we don't need to multiply this by x minus 7. This fraction, however, needs the x plus 7 to have a common denominator. So that's all we need to do. Just multiply this by x plus 7. So the left fraction is fine. So we're just left with 4 over x minus 7, x plus 7. And then on the right fractions, I think we're finding the sum, so we're going to add these. I'm going to switch that around just to make it easier, because that's the way it looks normally when we're multiplying binomials. So we're going to get on the top x squared plus 12x plus 35. That's just multiplying two binomials together. Feel free to use the box method if you prefer that, but that's how I got it. Right, x plus 5, x plus 7. Then over x minus 7, x plus 7. So when we add these, we're just adding 4, so we end up with x squared plus 12x plus 39. Now, before you stop, it's important to factor the bottom, because it's possible that the top and the bottom, oops, excuse me. Let me pause for a minute. Sorry about that, I'm uploading the other video as I'm making this one. So it's possible that the top of this fraction has a factor in common with the bottom, so we're going to factor this if possible. So factors of 39 are 1 and 39, 2 and nothing, 3 and 13, that doesn't work. These are both prime, so I think that's it. Right. 4, no, 5, 6, 7. I'm pretty sure that's it. So nothing factorable, so that's it. So that's the final answer. Moving on to 14. Again, I'm not gonna put a problem like 14 on the test. Don't worry about that one. We'll skip to 15 in the interest of saving some time here. Now we're solving equations. Check your solutions. I believe what it means there is check for extraneous solutions, so always do that. Here, what I want to do is get rid of the fractions. So instead of adding the fractions, which we could do by finding the common denominator, I prefer getting rid of the fractions by finding the common denominator, which is 3n. So I'm going to multiply everything by 3n. To make it look like a fraction, I could do that. When I multiply 3n times 1/3, these 3's cancel out because these are all factors. There's no addition when I'm multiplying this to this only. So these 3's would go away. I'm not going to cancel them because I need to multiply this 3n to the 5/n in a moment. But we can just picture that. These 3's are going to cancel, leaving in n times 1/1. So leaving in n. And then when I multiply this 3n times the 5/n, the n's cancel, leaving 3 times 5. So we have plus 15. And then when I multiply over here, these n's cancel, because again, these are all factors. There's no addition or subtraction. Leaving 6 times 3 is 18. So from here, it's a very simple problem. It's n equals 3. It's important to double check, see if that works. So let's do that. 1/3 plus 5/3 equals 6/3. Sure enough, that's true, so this is the correct answer. Alright, so I'm going to finish this video, and then we'll finish up in the next video.